There's a plant growing in ditches and cracks across North America right now that produces more protein per acre than corn, requires half the water, and thrives in conditions that would kill most crops. Farmers spend billions every year trying to destroy it. Agricultural scientists call it the most troublesome weed in the country. And 500 years ago, a conquering empire was so terrified of what this plant represented that they burned every field of it they could find and cut off the hands of anyone caught growing it. The plant is amaranth, and what you don't know about it is costing you, the sacred grain they tried to erase. The first thing that makes amaranth different from anything else in your garden is its history. Not just where it comes from, but why it almost disappeared entirely from human use. 8,000 years ago, the people of Mesoamerica domesticated amaranth alongside corn and beans. It became one of the three foundational crops of the Aztec civilization. Tribute demands from conquered peoples required amaranth deliveries alongside corn and other goods. The scale of production was enormous. This wasn't a fringe food or a supplement. It was a staple that helped feed an empire of millions. And unlike corn and beans, amaranth was considered sacred. The Aztecs called it huatli, and they used it in their most important religious ceremonies. They would pop the tiny seeds like miniature popcorn, mix them with honey and sometimes blood, and form them into shapes of their gods. Entire families would then consume these figures as a way of taking the divine into themselves. The plant was woven into every aspect of life, from daily nutrition to spiritual practice. When Hernán Cortés and the Spanish conquistadors arrived in 1519, they immediately recognized the problem. This plant was not just food, it was identity, it was resistance. It was an entire belief system compressed into a seed smaller than a pinhead. The ceremonies involving amaranth looked, to Spanish Catholic eyes, disturbingly similar to communion, a food being transformed into a divine body and consumed by believers. The parallel was too close for comfort, so they banned it. They burned every amaranth field they found. They imposed brutal punishments on anyone caught growing it or saving its seeds. According to historical accounts, Cortés himself ordered that the hands of cultivators be cut off. The Spanish understood something that most modern gardeners still haven't grasped. The power of a plant is not just what it produces, but what it makes possible. Control the food supply and you control the people. Eliminate a sacred plant and you eliminate the religion built around it. The ban worked at least partially. Amaranth cultivation in Mesoamerica declined by over 90%. Corn and wheat became dominant. The indigenous food system that had sustained civilizations for millennia was dismantled and replaced with European crops and European control. And here's what the conquistadors didn't count on. Amaranth is impossible to exterminate. It survived in hidden gardens, in mountain villages, in the quiet defiance of indigenous farmers who passed seeds down through generations. In some remote areas, the plant was grown in secret for centuries. The very qualities that made it a formidable crop made it an unstoppable weed. Its seeds scatter everywhere. They remain viable in soil for years. They germinate in conditions that kill competing plants. Today, 500 years after the Spanish tried to wipe it from the earth, amaranth grows on every continent except Antarctica. It appears uninvited in fields, gardens, and sidewalk cracks. The plant the conquerors tried to erase has become one of the most successful species on the planet. In Mexico, the traditional candy called alegria, made from popped amaranth and honey, is sold on street corners in every major city. The Dia de los Muertos celebrations feature amaranth skulls with raisin eyes and peanut noses, a direct continuation of the pre-Columbian practices the Spanish tried to eliminate. The fact that amaranth still exists, that people are still popping it and eating it, has been called a middle finger to the conquistadors. One horticulturist at the UC Botanical Garden put it this way: the survival of this plant, with people still consuming it 5 centuries after it was outlawed, represents an act of revolutionary resistance by the indigenous farmers who refuse to let their food culture die. And now, you can grow it too. The protein problem it solves. The second reason amaranth stands apart is the quality of what it produces. Most people who garden or farm are focused on calories. How much can I grow? How many pounds per square foot? But calories are easy. What's hard is protein, and specifically complete protein. Corn has protein, but it's missing lysine, one of the essential amino acids your body cannot manufacture on its own. Wheat has protein, but it's also deficient in lysine. Plus, it contains gluten that millions of people cannot tolerate. Rice has the same lysine problem. This is why traditional cultures around the world developed the practice of combining grains with beans. Beans have the lysine that grains lack. Together, they form a complete protein. Separately, neither one is nutritionally adequate. Amaranth breaks this pattern entirely. Amaranth seed contains 14 to 16% protein, which is higher than almost any true grain. But more important than the quantity is the quality. Amaranth contains all the essential amino acids in proportions close to what the human body actually needs. The lysine content is particularly high, 3 to 4 times higher than wheat. According to the Food and Agriculture Organization, amaranth protein is superior in both content and quality to traditional cereals. What does this mean in practical terms? It means you can eat amaranth as your primary carbohydrate and still meet your protein needs without adding beans, meat, or other complementary foods. For a gardener trying to maximize nutritional output per square foot, this simplifies everything. One crop does the work of two. The protein in amaranth is also highly digestible. Unlike some plant proteins that are locked up in forms the body struggles to absorb, amaranth protein is bioavailable. Your body can actually use what you're eating. Some researchers have found that amaranth proteins are among the most similar to animal proteins in the entire plant kingdom. The amino acid profile nearly matches what human nutrition requires. In studies comparing plant proteins to animal proteins, amaranth consistently ranks as one of the closest matches. Some researchers describe it as the most nutritious plant-based protein source available. It's why NASA selected amaranth as a potential food crop for long-duration space missions. When you're trying to keep astronauts alive with minimal resources, you don't choose a crop that requires complementary foods to achieve nutritional completeness. You choose the crop that delivers everything in one package. For anyone interested in food security, self-sufficiency, or simply reducing dependence on industrial agriculture, this single characteristic changes the calculation entirely. One crop, complete protein, no beans required. The water equation, the third advantage, is one that will matter more every year for the rest of our lives. Water. Corn is a thirsty crop. It requires consistent moisture throughout its growing season, and in dry years, yields collapse. The Corn Belt of the American Midwest exists because of reliable rainfall and massive irrigation infrastructure. Take either of those away, and corn production becomes marginal at best. In drought years, entire counties watch their corn wither in the fields, representing not just lost income, but wasted seed, wasted fertilizer, and wasted land for that season. Amaranth evolved in the semi-arid regions of Mexico and Central America. It developed the C4 photosynthetic pathway, the same biological mechanism that makes plants like sugarcane and sorghum so efficient in hot conditions. This allows amaranth to capture carbon dioxide and convert sunlight into biomass, with significantly less water loss than most crops. The stomata, the tiny pores on leaves that let carbon dioxide in and water vapor out, operate more efficiently. The plant gets more photosynthesis done per unit of water sacrificed. According to agricultural research, amaranth requires less than half the water of corn and less than half the water of wheat. Some studies show amaranth needing only 40 to 50% of the water that maize demands for equivalent biomass production. In trials conducted in arid regions, amaranth has been shown to produce a harvest in conditions where corn would not even survive to maturity. One researcher in New Mexico reported that amaranth bore seeds no matter how dry the season, while corn on the same property required minimum rainfall before it would produce ears at all. The drier the weather, the smaller the amaranth yield. Of course, but there was always a yield. Corn had a threshold below which it simply failed. Amaranth had no such threshold. This drought tolerance is not just about survival, it's about consistent production. Farmers growing amaranth during severe droughts have reported that while their corn neighbors had no harvest at all, their amaranth performed fine. The plants can actually wilt temporarily during extreme heat, then bounce back after rain in a way that corn cannot. They have a resilience built into their biology that allows them to pause and restart, rather than dying outright. Growers estimate that amaranth requires about half the moisture that corn needs. In regions where water is limited, this means you can grow twice as much food, or the same amount of food with half the irrigation. Either way, the economics shift dramatically in amaranth's favor. As climate patterns become more erratic and water becomes more expensive, crops that can produce food with minimal irrigation will become increasingly valuable. Amaranth was already adapted for exactly these conditions. It's been waiting for the rest of agriculture to catch up. The fertilizer advantage. The fourth point is related to water but often overlooked: nutrient efficiency. Corn is notorious for its heavy feeding requirements, particularly nitrogen. Growing corn depletes soil quickly and requires substantial fertilizer inputs to maintain yields year after year. This is expensive, energy-intensive, and environmentally damaging. Much of the fertilizer applied to corn fields washes into waterways, contributing to dead zones in the Gulf of Mexico and elsewhere. Amaranth has moderate fertility requirements, comparable to sunflower rather than corn. It needs roughly half the nitrogen inputs that corn demands. Research shows that 40 to 80 pounds of nitrogen per acre is adequate for amaranth, compared to 150 to 200 pounds or more for high-yielding corn. This lower requirement has cascading benefits. Less fertilizer means lower input costs. It means less dependence on synthetic nitrogen production, which consumes enormous amounts of natural gas. It means less runoff pollution. And it means the soil beneath your amaranth patch isn't being strip-mined of nutrients the way conventional grain fields are. For home gardeners and small-scale growers, this translates into a simpler operation. Amaranth will grow in less than perfect soil. It will produce a harvest where finicky vegetables would struggle. It's forgiving in ways that make it ideal for people who don't have the time or resources for intensive soil management. The entire plant is food. The fifth advantage is something most people don't realize about amaranth at all. You don't grow it just for grain. You grow it for leaves, for stems, and for seeds, all from the same plant. Amaranth greens are eaten throughout Asia, Africa, the Caribbean, and parts of Latin America. In these regions, they're not considered exotic health food. They're considered vegetables prepared in soups, stir-fries, curries, and stews. In India, amaranth leaves are made into dal called Thotakura papu, or steamed into thorin. In China, the leaves and stems are common in stir-fries and soups. In Jamaica and the Caribbean, amaranth greens are the foundation of callaloo, a beloved traditional dish. In Greece, a green amaranth called vileta has been eaten for generations. The leaves taste somewhat like spinach, but are more robust, holding up better to heat and drought than spinach ever could. While spinach bolts and turns bitter at the first sign of summer heat, amaranth thrives. It keeps producing tender, edible leaves through conditions that would destroy your spinach patch entirely. Nutritionally, the greens are exceptional. Studies comparing amaranth leaves to spinach and chard found that amaranth has more protein, nearly twice the vitamin C, and higher levels of calcium and iron. The leaves contain one of the highest concentrations of vitamin K of any edible green, providing 950% of the daily requirement in a single 100-gram serving. They're also rich in folates, vitamin B6, riboflavin, and numerous other B vitamins. Some nutrition experts argue that amaranth leaves are genetically closer to their wild ancestors than other cultivated greens, which means they've retained nutritional density that has been bred out of more common vegetables. The argument goes that modern lettuce and spinach have been selected for size, color, and shelf life, while their actual nutrient content has declined. Amaranth, still close to its wild form, delivers what vegetables were supposed to deliver all along. Young amaranth stems are also edible, containing both soluble and insoluble fiber. They can be cooked like asparagus, added to soups, or blended into smoothies. The texture is similar to green beans when cooked properly. One enthusiastic grower reported putting the entire plant, leaves and young stems, into morning smoothies for a nutritional boost that's hard to match with any store-bought vegetable. This means amaranth provides multiple harvests from a single planting. You can harvest young leaves throughout the summer as the plant grows, then let the remaining plants go to seed and harvest grain in the fall. One crop, three different food products. Very few plants offer this kind of flexibility. Most garden vegetables give you one thing. Amaranth gives you a salad green, a cooked vegetable, and a grain from the same seed. Packet, for people interested in maximum yield per square foot, this multiplies the value proposition substantially. You're not choosing between growing greens or growing grain. You're doing both simultaneously from the same seed. The multiplication affects the sixth reason to pay attention to amaranth is its reproductive capacity, which borders on absurd. A single amaranth plant can produce anywhere from 100,000 to 500,000 seeds in a season. The seed heads on some varieties can weigh up to a kilogram each. 1 pound of seed plants roughly an entire acre. And because the seeds are so tiny, storage is remarkably efficient. Hundreds of thousands of seeds fit in a jar that would hold maybe a few hundred kernels of corn. This matters for several reasons. First, it makes seed saving trivially easy. You will never run out of amaranth seeds once you've grown it successfully one time. The plant produces so many seeds that losing a significant portion to birds, insects, or harvesting losses still leaves you with more than you could possibly use. Second, it creates what some food security analysts call a high grow-out ratio. Starting with 1 pound of amaranth seed, you can produce over 1,000 pounds of grain in a single season. Starting with that harvest and replanting, the numbers become astronomical within just a few cycles. In emergency food production scenarios, this multiplication effect is enormously valuable. One small cache of seed can rebuild an entire food supply faster than almost any other crop. Third, this abundance means amaranth essentially plants itself. Let a few plants go to seed in your garden, and they will return next year uninvited. This is why the plant persists as a weed so successfully, and why it survived 500 years of attempted eradication. Once established, amaranth takes care of itself. Why farmers hate it. The seventh point explains the paradox in this video's title. Why would anyone declare a plant this productive, this nutritious, and this resilient to be a problem? The answer is Palmer amaranth, a wild relative of the cultivated grain amaranth, which has become the most feared agricultural weed in America. In 2017, the Weed Science Society of America voted Palmer amaranth the country's most troublesome weed. It can grow up to 3 inches per day under optimal conditions. Kansas State University research found that Palmer amaranth height increases at twice the rate of redroot pigweed and more than 40% faster than water hemp, another problematic weed. A single plant can reach 8 to 10 feet tall and produce over 500,000 seeds. It emerges continuously throughout the growing season, from May through September in the Midwest, making it nearly impossible to control with a single herbicide application. The narrow application window is part of what makes Palmer amaranth so devastating. Post-emergence herbicides need to be applied when the weed is still small, typically under 4 inches. But Palmer amaranth can grow past that threshold in a matter of days. By the time a farmer notices the problem, the window has already closed. The rapid growth means the plant escapes control before the control can happen. But the truly terrifying characteristic is its capacity to evolve herbicide resistance. Palmer amaranth has developed resistance to 8 different modes of herbicide action, including glyphosate, the active ingredient in Roundup. Some populations are now resistant to multiple herbicide classes simultaneously. Research has shown that the plant can amplify its own DNA to produce hundreds of copies of genes that break down herbicides, essentially overwhelming the chemical before it can work. This is not ordinary adaptation. Scientists discovered that Palmer amaranth uses extrachromosomal circular DNA, essentially mobile genetic material outside its normal chromosomes, to rapidly copy and disseminate resistance genes. The plant's genome can rearrange itself to stack resistance to multiple herbicides in the same population. A study published in 2025 confirmed that some Palmer amaranth populations now carry dual resistance to both glyphosate and glufosinate on the same circular DNA element. The weed is evolving faster than the chemical companies can develop new products to kill it. In corn and soybean fields, uncontrolled Palmer amaranth can reduce yields by 50 to 91%. The plant outcompetes crops for nutrients, water, and even sunlight, growing tall enough to shade out corn. In cotton fields, the thick woody stalks can actually clog combine harvesters, stopping the machines entirely. Farmers describe spending twice as long harvesting for half the yield, and even then, portions of fields may be unharvested because the equipment cannot handle the weed density. The economic damage is measured in billions of dollars annually across the agricultural sector. This is why agricultural institutions treat amaranth as an enemy. From the perspective of industrial monoculture, anything that competes this effectively with cash crops is a threat that must be destroyed. Weed scientists recommend a zero-tolerance approach, meaning any Palmer amaranth plant that escapes initial control must be removed by hand before it can set seed. The plant has become so problematic that farmers are harvesting infested fields last to avoid contaminating their equipment, and hand-pulling escapes to prevent seed rain from rebuilding the weed seed bank. But step back and consider what this weed is actually demonstrating. It survives drought better than the crops it grows alongside. It produces more biomass on less water and fewer nutrients. It reproduces so prolifically that it can rebuild its population from a handful of escaped seeds. It evolves resistance to chemical control faster than the chemical companies can develop new products. These are the exact same traits that make cultivated amaranth such a valuable food crop. The difference between a weed and a harvest is simply whether you planted it on purpose. The gluten-free question, the 8th reason amaranth deserves attention, is its compatibility with dietary restrictions that affect millions of people. Celiac disease, an autoimmune condition triggered by gluten, affects roughly 1 in 140 people in the United States alone. Many more experience non-celiac gluten sensitivity. For these individuals, wheat, barley, and rye are completely off the table. The usual grain alternatives include rice, corn, and various specialty flours that often come with nutritional or practical trade-offs. Amaranth contains no gluten whatsoever. It's not a grass, so it doesn't produce the proteins that cause problems for gluten-sensitive individuals. This makes it suitable for anyone following a gluten-free diet, without the need for special processing or certification. But unlike rice, which is essentially empty carbohydrates, or corn, which is missing key amino acids, amaranth provides the nutritional density that gluten-free diets often lack. The complete protein profile, the mineral content, the fiber, all of these help compensate for the foods that people with celiac disease must avoid. For families managing dietary restrictions, adding a productive, easy-to-grow, gluten-free grain to the garden is a meaningful hedge against food uncertainty. An amaranth requires no special knowledge or equipment to prepare. You cook it like rice, grind it into flour, or pop it like popcorn. The cooking flexibility, the ninth advantage, is purely practical. Amaranth is remarkably versatile in the kitchen. The seeds can be cooked whole, like rice or quinoa, producing a porridge-like consistency that works for breakfast cereals or savory side dishes. Use roughly 1 part amaranth to 2 to 3 parts water. Bring to a boil. Then simmer for 20 to 25 minutes until the water is absorbed. The result is slightly sticky, with individual seeds retaining a pleasant pop when you bite them. They absorb flavors well and have a mild, slightly nutty, earthy taste. That doesn't overpower other ingredients. Unlike quinoa, amaranth seeds have no saponin coating that needs to be rinsed off before cooking. You can take them from storage to pot without any special preparation. This small convenience adds up when you're cooking regularly. The seeds can be popped, using just a dry pan over medium-high heat, no oil required. Heat the pan until it's hot. Add just a tablespoon of seeds at a time so they don't pile up, and shake the pan continuously. The seeds will begin popping within seconds, turning from dense little spheres into tiny white puffs. Remove them quickly before they burn, as the window between perfectly popped and scorched is narrow. The result is something like miniature popcorn, light and crunchy, suitable for topping salads, yogurt, or granola. In Mexico, this popped amaranth mixed with honey, agave, or sugar syrup is sold as alegría, meaning joy, a traditional candy that dates back to pre-Columbian times. The same basic preparation has been made continuously for thousands of years, one of the oldest candy recipes on the planet. The alegrías are formed into bars, skulls for Day of the Dead celebrations, or simply irregular shapes wrapped in cellophane and sold by street vendors. The seeds can be ground into flour and used in baking, either alone or blended with wheat or other flours. Amaranth flour adds protein and nutrition to breads, muffins, pancakes, and other baked goods. Because amaranth lacks gluten, it won't develop structure on its own the way wheat flour does. Most bakers recommend using amaranth flour for up to 25% of the flour in a recipe, blending it with wheat for the best texture. The leaves can be eaten raw in salads when young and tender, or cooked like spinach when more mature. They hold up well to high heat and don't turn slimy like some tropical greens. The taste is mild enough to substitute in almost any recipe calling for spinach, chard, or other cooked greens. Many people find the flavor actually better than spinach, with a slight sweetness and none of the metallic edge that spinach sometimes has. This range of applications means amaranth doesn't require you to learn entirely new cooking techniques or acquire specialized equipment. If you can make oatmeal, you can cook amaranth. If you can sauté spinach, you can prepare amaranth greens. If you can make popcorn, you can pop amaranth seeds. The plant fits into existing food patterns rather than demanding you create new ones. The growing simplicity, the 10th reason to consider amaranth, is that it's genuinely easy to grow, far easier than many common garden vegetables. Amaranth is a warm season crop, planted after the last frost when soil temperatures reach at least 60 to 65 degrees Fahrenheit. Best germination happens when soil temperatures are between 65 and 75 degrees. A good rule of thumb is to plant amaranth at the same time you would plant sweet corn or lima beans in your area. The seeds are tiny, with roughly 600,000 seeds per pound, so they need to be sowed shallowly. 1/8 inch deep is about right. You can simply scatter the seeds on prepared soil and rake them in lightly. Some growers recommend leaving the soil slightly loose over the seeds to prevent crusting, which can block the tiny seedlings from emerging. Water gently after planting and keep the seedbed moist until germination, which typically takes 4 to 10 days depending on temperature. One remarkable characteristic of amaranth is that seeding rate doesn't matter much. Field studies in Missouri showed that amaranth yields were fairly constant, across a range of 1/4 pound to 4 pounds of seed per acre. The plant compensates, Plant densely, and individual plants stay smaller. Collectively produce similar yields. Plant sparsely, and each plant grows larger and more productive. This forgiveness makes amaranth ideal for beginners who aren't sure about proper spacing. Once established, amaranth requires minimal attention. It tolerates heat that would devastate lettuce or spinach. It handles drought that would stunt beans or squash. Native Americans and Aztec farmers grew amaranth in arid and desert regions with minimal water. One grower reported watering amaranth only once every 1 to 2 weeks, far less than most vegetable crops demand. The plants grow slowly during the first few weeks, staying small and somewhat vulnerable. This is when weed competition matters most. Keep the area weeded until the plants reach about a foot tall. After that point, amaranth begins growing rapidly, sometimes 3 or more inches per day under optimal conditions. At this stage, the plant outcompetes most weeds by shading them out entirely. The thick canopy blocks light from reaching the soil surface, and late-emerging weeds simply cannot establish. Pests are generally not a significant problem. While some insects feed on amaranth, including tarnished plant bugs, flea beetles, and blister beetles, the plant can tolerate substantial leaf damage without meaningful yield loss. It doesn't require the constant monitoring and intervention that crops like tomatoes or brassicas demand. Only rarely do insect populations build to levels requiring treatment. At harvest time, the grain can be collected by simply cutting the seed heads after the first frost has killed the plant and dried it down. Allow the heads to dry further if needed, then rub or thresh them to release the tiny seeds. The seeds can be winnowed by pouring them between 2 containers in a light breeze, letting the chaff blow away, while the heavier seeds fall into the receiving container. For gardeners who want a high-yield, low-maintenance crop that can handle neglect, amaranth is nearly ideal. It asks for very little and produces a great deal in return. The climate adaptation, the 11th consideration, is the plant's suitability for the environmental conditions we're moving toward, not the ones we're leaving behind. Most of our agricultural system is optimized for the climate patterns of the 20th century. It assumes reliable rainfall, moderate temperatures, and stable growing seasons. Every year, those assumptions become less accurate. Droughts are more frequent. Heat waves are more intense. Growing seasons are shifting in unpredictable ways. Amaranth thrives in exactly the conditions that stress conventional crops. It performs well in heat. It survives drought. It produces food on marginal land with poor soil. It's been called a climate-smart crop by researchers who study food security under changing conditions. This doesn't mean amaranth is immune to climate stress. Severe conditions reduce its yields just as they reduce yields of any crop. But the baseline is higher, and the breaking point is much further away. In a future where water is more expensive, temperatures are higher, and weather is less predictable, amaranth maintains production while other crops fail. For anyone thinking strategically about long-term food production, this characteristic alone justifies giving amaranth serious attention. The crops that fed us in the past are not necessarily the crops that will feed us in the future. Amaranth is better positioned for what's coming than most of what currently fills our fields. The self-sufficiency factor, the 12th and final reason to understand amaranth, is what it represents for anyone pursuing genuine food independence. Most modern crop varieties require purchased seed, commercial fertilizers, regular irrigation, and chemical pest control. They're designed for industrial agriculture, optimized for yield under ideal conditions supported by expensive inputs. Remove any element of that support system, and production collapses. This is the hidden fragility of the modern food system. It looks productive, but it's dependent on a long chain of inputs that most growers don't control. Amaranth operates differently. It produces its own seed in such abundance that you will never need to buy more. A single successful season generates enough seed to plant for decades. It grows on moderate fertility without heavy fertilizer inputs. It survives on rainfall in climates where corn would fail without irrigation. It resists pests without intervention. This means amaranth can form part of a closed-loop food system where inputs are minimal and outputs are substantial. You're not dependent on seed companies, fertilizer manufacturers, or irrigation districts. You're working with a plant that evolved to produce food under marginal conditions, using only what the local environment provides. The cultivated grain amaranths have another advantage worth mentioning. They don't become weed problems. Unlike their wild relative Palmer amaranth, the grain amaranths have different characteristics. Their seeds are lighter in color, larger, and don't persist in soil the way wild amaranth seeds do. Fields where grain amaranth has been grown have not developed weed issues in subsequent years. The grain species are well behaved. You get the productivity without the invasiveness. For preppers, homesteaders, or anyone concerned about disruptions to food supply chains, this independence is invaluable. And for ordinary gardeners who simply want more food with less work and expense, amaranth delivers. It's a plant that asks very little and offers a great deal. It's been doing this for 8,000 years. If you've made it this far, you now understand something that most people never learn about the food system. There are plants that outperform our standard crops on almost every metric that matters. They're more nutritious, more water efficient, more resilient, and more productive. And they've been labeled weeds because they don't fit the industrial model. Amaranth is one of those plants. I'm not suggesting you replace your entire garden with it, but I am suggesting you grow some. Start small. A single row of amaranth, harvested for both leaves and grain, will teach you more about what's possible than 100 articles ever could. Watch it grow through heat waves that wilt everything else. Harvest the leaves for summer salads while your spinach bolts. Collect the grain in fall and pop it like tiny popcorn. Experience what it means to grow a complete protein from seed to harvest. If you found this valuable, consider subscribing. The people who watch this channel aren't looking for the easy path. They're looking for the smart one. And understanding plants like amaranth, plants that the system has dismissed or demonized, is exactly how you build real food security while everyone else stays dependent on a fragile supply chain. Pick one thing from what you've learned today, order the seeds, clear a small patch, plant it when the soil warms, and then watch a plant that conquered an empire grow in your own backyard. When the conquistadors burned those fields 5 centuries ago, they thought they were eliminating a threat. What they actually did was prove that some plants and some knowledge cannot be destroyed. You now have that knowledge. The question is what you'll do with it. I'll see you in the next one.